Namaskar children. Welcome to the second part of the lesson on statistics. In the earlier part, you have learned and applied the concepts of mean as a measure of central tendency. In this part, you will be learning about median. A brief introduction to median was given in the previous lesson as well. To begin with the definition of median, it is as simple as the middle piece of data when the data is arranged in order. For this, I would like to take you back to the example of statistical measures used in ancient history, which was referred to in the previous lesson. Here, in order to estimate the number of fruits on a tree, the branch which was chosen as a representative of the other branches was a branch which would have the number of fruits which lay somewhere midway between the branch having the minimum number of fruits and the branch having the maximum number of fruits. The technique used in this regard was median. Let us look at an example in order to understand how the median is calculated for any given data set. So here, as you can see, we have values 8, 7, 4, 9, 8, 6, 7, 6 and 8, and we need to find out the median of this data set. Whenever we need to find out the median, the first step is always arranging the data in order. It could be ascending or descending order, but we need to arrange the data in order. So over here, I'm trying to arrange this in the ascending order. So 4 being the smallest value, we start with 4. Followed by 6 appears twice in the list. 7 also appears twice in the list. And we have 8, which is appearing thrice, followed by the last value, which is 9. And as we can see over here, we have a set of 9 values. So the value of n is 9. Now the general formula to find out median is always to look out for the value at the n plus 1 over 2 position. So we always look out for the value at this position. So with reference to this particular example, we are going to be looking out for the value at 10 upon 2, which is equal to the value at the 5th position. And remember, this has to be done from the arranged data. So if we go by the arranged data, 1, 2, 3, 4 and 5, we arrive at the value 7. So that brings us to our simple answer. The median for this data set is equal to 7. Let us now look at another example. The data over here is very similar to the data in the previous example, barring the difference that we have one extra data element. So which means now the value of the value of n changes to 10, which is an even number of values as against the previous example wherein we had odd number of data elements. The formula still remains the same. So we're going to be looking out for the value at the n plus 1 over 2th position, which is 10 plus 1 over 2, 11 over 2, which is 5.5. Now since this is a decimal value, it actually implies that the median is going to be lying between the 5th and the 6th position. Or in other words, the median will actually be a value which is the mean of the values at the 5th and the 6th position. But again, going back to the first step, we first need to arrange this data in order. When arranged in order, 4, 6, 6, 7, 7, 8, 8, 8, 9, followed by 10. So now we're going to be looking out for the two values at the 5th and the 6th position. So 1, 2, 3, 4, 5 and 6, which brings us to these two values, which means our final answer is actually going to be the mean of these two values. Now you already know how to calculate the mean. We're just going to add up the two numbers and divide it by 2. Anyway, for 7 and 8, the values are fairly simple and we know that the answer is going to be a 7.5. So which brings us to the final answer for this example. The median in this case is 7.5. And that's the final answer for this example. Let us look at another example. Here we have a set of data which is given. We need to find out the mean and the median. Further, the next part of the question says, which average best describes the set of the numbers? So let us first find out the mean and the median, and then we shall take a look at which would, between the two, would be a better measure of central tendency. In order to find out the mean, we know all we need to do is sum of all the values divided by the number of values. Adding up these values will not be very difficult. 1 plus 3 plus 3 plus 3 plus 4 plus 6 plus 99, which actually gives us a total of 20 plus 99 divided by the total number of values in this case is 1, 2, 3, 4, 5, 6 and 7, which brings us to the answer of 119 divided by 7, which is equal to 17 when simplified. So that brings us to the value of mean as 17. Now let's go ahead and find out the median. As far as the median is concerned, we know the first step is to arrange the data in order. Over here, as we can see, the data is already arranged in the ascending order, so we don't need to bother much about that. And the number of values is 7, so the value of n is 7, which means we're going to be looking out for the value at the n plus 1 upon 2th position, which means we're going to be looking out for the value at the 4th position. 1, 2, 3 and 4, so the value at the 4th position is 3, which brings us to the answer that the median will equal 3. So there goes my answer into the answer box. The median is 3. Now, in order to answer the second part of the question as to which average best describes the set of the numbers, there is a lot of difference between the two values that we are getting. Mean is 17, whereas median is 3. Let us go back and have a look at the data that we have. Over here, if we notice, there is one value, 99, which is actually quite an extreme value if we were to compare it with all the other data elements. An extreme value or an outlier as it is called. Now in this case, a median would actually be a better representation of the rest of the elements as compared to the mean. So the conclusion is, in this case, or for that matter in any case, whenever we have extreme values which are appearing in the data, or we have outliers as they are called, these are values which are not falling within the range of the other data elements. In such a case, a median is a better representation of the average as compared to the mean. So that is one important point which needs to be noted, that when we have extreme values or when we have outliers, it is better to choose median as a measure of average over mean. Let us look at another question. Here we have the mean age of 3 people is 22 and their median age is 20. The range of their ages is 16. So basically we have three values. We have the mean as 22. We have median as 20. We also have range as 60. Range is another measure of central tendency, and I'm going to be telling you what range is and how we can apply it in this question. Alright, now since the mean age of three people is 22, let me just presume that the ages of the three people are X, Y and Z. So given the fact that mean is equal to 22, I can say X plus Y plus Z equals 22. On further simplification, I can also say X plus Y plus Z equals a 66. Alright, now by the second part, I also know median equals the value 20. Now over here, if I just presume that the order or the ascending order of the data is X, Y and Z, the median is going to be nothing but the value of the middle position, which in this case is nothing but Y. So my inference is that the value of Y, according to my assumption, should be equal to a 20. Now let us come on to the last part of the data which is given in the question. The question says range of this data is 16. Now you need to understand what is range as a statistical measure. Range is nothing but the highest value or the maximum value minus the lowest or the minimum value. According to our data, we presume that X, Y and Z are in order. So I can say that the range will be nothing but Z minus X, because Z becomes the highest value and X becomes the lowest value. So in other words, the information that I'm given is Z minus X equals 60. Now if we have a closer look, since I already know the value of Y as 20, I can substitute that value over here, and which gives me the inference that X plus Z will actually equal 66 minus Y, which is 20. So X plus Z equals a 46. Now if you have a closer look, I have two sets of equations and two unknown variables. So which means I can solve both of these like simultaneous linear equations. So when I do that over here, I can say, rewriting equation B beneath equation A, minus X plus Z equals 60. And when we add up both these values, the X is cancelled. So what we get is twice Z is equal to 62. So which means Z is equal to 62 over 2. Z is equal to a 31. Now once I have this value, all I need to do is substitute in any one of these equations in order to get the value of X. So if I substitute in say equation A, I can say X will be the same as 46 minus Z, or in other words, X will be the same as 46 minus 31, which means X will equal 50. So there you are. We have the answers to all the three ages, 15, 20 and 31. So there goes the answer into the answer box. The age of the first person is 15, followed by 20, and the last one is 31. Alright, so it is your turn now. I'm going to give you a few assignment questions. Work it out on the basis of your learning in this lesson and tally with the final answer. So here you have a set of data which gives you the amount spent by 15 students in their cafeteria, and you need to find out the median value of the amount spent. I'll give you the final answer. The final answer in this case should come out to be equal to $2.25. Here goes another question. The numbers 3, 5, 7, 8 and n are arranged in the ascending order. If the mean of the numbers is equal to the median, find n. So use concepts of mean and median in order to arrive at the answer. And if your final answer turns out to be 12, then you know that you are in the right direction. And now for the last one, the median in the form of a rhyme. I don't know the rhyme, I don't know the riddle. I am the median, I am in the middle. Watch out for the next part of the lesson in which you will be learning about mode as a measure of central tendency.